The donor should not have antibodies attacking. Recipient should not have antibodies attacking donor cells. This is one rule. Then I discussed the cross matching here. So cross matching we have two types. What are those? Major cross matching and minor cross matching. In minor, what we are taking? Donor cells plus recipient serum. Whereas in minor, donor serum plus recipient cells. Okay. Now listen. Usually what we will do is, I'll discuss. Then coming to blood grouping, there are methods of blood grouping. Now listen. See, if we are detecting antigen present on the surface of our body with the help of the known antibodies, such grouping is called as forward grouping. Forward grouping. Okay? In forward grouping, we are detecting an antigen, unknown antigen with the help of known antibodies. I will take A antibody and I will add to the blood. If there is a reaction, I can understand there is an A antigen. I have taken a B antibody. I added. If there is reaction, B antigen is present. So I am detecting unknown antigens with the help of known antibodies. That is called as forward grouping. Then there is an interesting test called reverse grouping. What is this reverse grouping? Any idea? Yeah. Now, from the patient, we will collect the serum. Then we will add the known antigen, known A group, B group, we will add to it. That is called reverse grouping. So, what will be the results in reverse grouping? For example, listen. In reverse grouping, I have added a anti. In reverse grouping, I have taken my test tube, and this test tube has the antibodies, patient unknown antibodies, patient antibodies. Then I have added A group cells, group A cells to this test tube. Okay. Now I got a reaction. My antibodies, my red blood cells are destroyed. What does this indicate? What is the group of this patient? I have added A group cells, then I got a reaction. When I added A group cells to my unknown patient, I got a reaction. That indicates my patient has A antibodies. In what blood group patient will have A antibodies? Wrong.
No, sir, B.
Now you understood, right? If my patient was B group, then only he will have A antibodies.
Yes, sir.
So this is reverse.
Yes, sir.
Got my logic? If I added B cells and if I get a reaction, what does the blood group indicates?
Sir, A.
A group. If there is no reaction, what does what group is this? I added A group cells and B group cells, but there is no reaction. Then?
Sir, AB.
I added A group and B group, but there is no reaction. Then definitely that will be a AB group. Correct. There is AB group.
Yes, sir.
Yeah. So now you understood the logic, right?
Yes, sir.
Yeah. Then O cells also we need to take. When we add O group, if we get a reaction, will we get a reaction if I add O group cells? In O group, both there will be A and B, so definitely there will be reaction. If patient is O group, he will have antibodies. So definitely this will be lysed.
Yes, sir.
Will it lyse? No. A or B will lyse, not O cells.
Yes, sir. उसके बाद तो
correct. Alright. So this is called reverse grouping. What is your thoughts on reverse grouping? Is reverse grouping necessary?
Yes, sir.
Why?
सर क्योंकि एंटीबॉडीज को डिटेक्ट करना जरूरी है सर.
Yeah, sometimes we need to screen the antibodies in the patient, not only antigens, but sometimes maybe those plasma antibodies might attack in donor cells. So we need to cross-check the antibodies also. So reverse grouping also mandatory. Then the next one, I just need to tell physiology. Listen, in the red blood cell, first we have a ground substance. The ground substance is called as H antigen. We are not discussing H antigen regularly, but H antigen will determine three things. H will be converted to HA antigen, that will be A group. It will be converted to HB antigen, that is a B group. And this will also convert H null antigen. H null antigen will be O group. So previously what we thought? We thought that in the O group there is no antigen. But still in the O group there is a H antigen. H antigen present in all the groups. Got my point? So keep this H antigen. I will let you know why this is important. So in Mumbai we got a new case. In Bombay what happened was, they got a O negative recipient. The patient was O negative. He is the receiver. He needed O negative blood. He is O negative person. So what they did? All right. Definitely O negative is a universal donor. And my patient also O negative only. So we proceeded with confidently. We identified a O negative donor, and we have given his blood to the patient. Assuming, even though if he has any antibodies, those antibodies won't attack the cells. Assuming the antibodies won't attack the cells. Hello, yes ma'am. Yes ma'am. Good afternoon. Ma'am, I have 140 meter class. Yes ma'am. Okay. After 2 then I will. What I am saying?
Sir.
O negative group, blood be given to O negative patient. But somehow, even if he has any A or B antibodies, in O group we have A and B antibodies, they cannot destroy these O negative cells. Ideally, there should not be any reaction in this patient. What my point? You didn't get it. In O negative, his blood was O group. What antibodies he might have? He have A antibody and B antibody. Okay. We know that A and B antibodies are present. But are we giving any group? Here we are giving O group only. And O group don't have any antigens.
Yes, sir.
So ideally he should not get any reaction in this transfusion.
Yes, sir.
This is a very good reaction.
Yes, sir.
Good blood transfusion. Universal donor only.
Yes, sir.
And any group, what is the meaning of universal donors? All groups will accept their blood.
Yes, sir.
All groups will accept because they are O group.
Yes, sir.
But interestingly in Bombay, they were surprised. The patient has collapsed. Patient died in 3 to 4 hours. His entire blood clotted. And they were shocked. What happened in this? Then what they did? They went and they took their glass slide. This is a recipient, this is a donor. He took the donor cells and they took the recipient antibodies. Ideally, these antibodies cannot attack O group. Recipient antibodies cannot attack O group individuals, O cells. But interestingly, they are attacking. What's going on? So scientists, they become very curious. What's happening in this patient? And these patients, In India, we have only 5 to 10 patients like this. It's one of the rarest group, where O group individuals has developed something that is attacking them. Okay. Then when they saw this patient not only having A antibody, B antibodies, but this patient also developed a new antibody, that is anti-H antibodies. They were surprised. Anti-H antibodies. And I said that even in O group there is a H antigen. So these patients cannot accept any blood in this world. None of the blood will be compatible to them. Because all the people has H antigen as a common antigen on all the red blood cells. And these people are in 1 person in 10,000 population. Identifying these patients is very tough. Why this is very tough? Because if you do normal blood grouping on their blood sample, we will assume they are more negative individuals.
Yes, sir.
And very rarely they will go for transfusion. Then only we will go for cross-matching to identify this issue. And they usually we will miss them. We will lose them because of asymptomatic condition. Now, what happened with this with them? They need a blood which don't have H antigen. That means they can only receive blood from their own people. There should be another rarest person, only he can donate to him. We need to identify another rarest such group patient. This group is called as Bombay blood group. Very rare. Bombay blood group. The test is around very costly, 10,000 to identify Bombay blood group. One of my friends working in Chennai blood bank and he found a Bombay group accidentally. He said. So if we came to know there is a Bombay group, definitely we will maintain a registry in online database. If anyone need immediately, we will send his blood sample. So yeah, Bombay blood group is very interesting. Then on this thing, I need to tell you other groups which we are not studying. The other groups are ABO, then Bombay group, then KIT, Diabo, Duff, Kel. Then we have almost 20 groups. 20 different types of blood groupings are there. They are rare actually. Yeah. Now, in blood banking, we thought we will only do cross matching with ABO. But even in A group, we have A1 and A2. And they will have some minor reactions also, B1, B2. Even A3 also there. These are sub-antigens. It's not a complete antigen, it's a part of antigen. Not completely A antigen, but a partial A antigen is present. Again, for them what happens was, when we do the grouping, in grouping, they looks like a O group, but they are A group only. Their antigen is very small, so we are unable to detect them. What we will assume is a O group. But unfortunately, this O group, they will have antibodies, B antibodies. If you will, see any group, definitely they will get a reactions. So, yeah. Such partial antigens are called as it's a word for incomplete antigens. Such partial antigens are called as incomplete antigens. Now there is a problem with the incomplete antigens. In these patients, due to their incomplete antigen here, antibodies are already sensitized there. Some foreign antibodies will be sensitized. And these antibodies, sometimes, if you get a bacterial infection, E. coli infection, this E. coli will trigger these antibodies and they will get a hemolysis. Due to some other infection, their blood will be lysed. So these are called as the subsets. Now open your first assignment questions. Tell me what are those questions. Tell me. You already got right. First assignment questions. What are those?
The first question is what is ABO grouping and its objectives?
ABO grouping, you know. That question answer, you know. On our next second one.
Sir, who discovered the ABO blood group and
Who discovered ABO?
You know, who discovered ABO, Carl RH level
Yes,
and RH by
IgG.
Alexander
Yes.
Very good. Next.
So differentiate between ABO system and RH factor.
Difference between ABO grouping and RH factor. RH factor will determine positive and negative.
Yes, sir.
ABO will determine the groups.
Groups.
8 groups. Next.
Sir, list 2 common sources of errors in blood banking.
What are the errors? What we wrote? What is the answer?
So clerical error and technical error.
Clerical error
And technical error.
Yeah. What is the example for clerical error?
सर क्लरिकल एरर्स सर वो होते हैं जैसे
Sir, mislabeling or labeling of
mislabeling.
samples.
Yeah. Yeah. See, listen. We can take. Okay, mismatched blood transfusion. Unidentified patient doing the test. That is clerical error. What is analytical error?
टेक्निकल एरर सर reagents और वो मतलब
During the testing process. Tell me what is your name? Dinesh.
Sir, Rajiv.
Raja, yes, Raja, tell me what is your answer?
Sir, improper sample handling, contamination.
Yeah,
use of
improper sample handling. See, I have 3 drops of blood. Then I added anti-sera A here, B antibodies here, and RH antibodies, that is B antibodies here. Now what I did, I took a stick. This is a blood drop and this is antibodies. I mixed them. Okay, now my stick has some A antibodies. If I use the same stick here, I was contaminating B with A antibodies. I should use the other side of the stick to mix the B antibodies. Then I should use a new mixing stick for third one. If you forgot or if when you are shaking it, if these drops are mixed together, you will get wrong results. So that is analytical errors. Expired reagents, mixing the sample. Then third important thing, at least 2 minutes we need to wait to get the agglutination reaction. Okay, this reaction is called as agglutination reaction. We have multiple reactions: agglutination, precipitation, flocculation. So there are a few things. Anyway, yeah. Next question.
Sir, highlight 2 key difference between complete and incomplete antibodies.
Yeah. Differences between complete and incomplete antibodies. Just like our complete and incomplete antigen, even in antibodies we have complete and incomplete antibodies. The only difference is complete antibody, if it binded with red blood cell, it will destroy the cell. Incomplete antibody, if it binded, it won't destroy it, but it will sensitize the cell. A secondary antibody must attach to this primary incomplete antibody, then it will destroy it. So what is the notes there? Tell me the content. What is complete and incomplete antibody? Yeah. See in my notes, if you go to the 5th question in table of content, click the question, it will go to the answer directly. In the starting page, click the question, you will get the answer. Can you able to do? That's why I said you to bring this one. Printed material, but you didn't see. Your own things you are not following. Very bad. Very, very bad. And it is recorded also. Let me go there. Let me complete. Here it is. Yeah. Do you want the answer? Did you have the answer there?
Yes, sir.
What is it?
So these antibodies can cause agglutination of antigens. Incomplete antibodies these antibodies cannot directly agglutinate antigens.
Yeah, incomplete cannot directly agglutinate. They need a second. Then how they will agglutinate them?
They require tests like indirect comb test to detect their presence.
Yeah, very good. Yes. Now those sensitized. If you remember, HDM, hemolytic disease of newborn.
Yes, sir.
Here what happened? Mother developed anti-H antibodies, RH antibodies, and those antibodies are incomplete antibodies. These antibodies are binding to the, now I realized. Wait. Mother got a pregnancy. Due to this pregnancy, baby came out. Then baby's positive positive antibodies. Now these positive antibodies will be coated in all the mother red blood cells. All red blood cells will have this Rh positive antibody, but they won't destroy mother cells. But how to detect these antibodies? Now what we have done was, we have taken these Rh antibodies, we given these antibodies to a rat or a rabbit. Listen very carefully. I have given Rh antibodies, positive antibodies to a rabbit. You know what happens in the rabbit? For rabbit, this antibody is an antigen now. It's a foreign particle for a rabbit. For us, this is an antibody. But for a rabbit, it's a foreign particle. Now what rabbit will do? It will develop antibodies against this antibody. Now we will collect these antibodies. We will take the rabbit serum and we cut this as a reagent. This reagent is called as Coombs reagent. Now we will use these antibodies. We will add this drop of antibodies here, and now those antibodies will bind to them, resulting in an agglutination. So this is how we can detect a Rh positive sensitized mothers, or such abnormal antibodies presenting individuals can be identified by using Coombs test. Now Coombs test is called, there are two types of Coombs test. If already cells are sensitized, we added a drop of Coombs reagent and we got a reaction. Such Coombs test is called as direct Coombs test. Now, there is a second scenario. Sometimes antibodies won't sensitize the red blood cell. Antibodies are freely available in the circulation. What to do in that case? What we will do is, we will take the patient's cells and we will also take the patient's serum. We will mix them, then we will incubate them for 37 degrees centigrade. So during this 37 degrees centigrade incubation for half an hour, the cells will be sensitized by their own antibodies. After this, we will add our Coombs reagent. Such a test is called as indirect Coombs test. In indirect Coombs test, we are adding this one, incubation phase in the test. That is called as the indirect Coombs test. Next question.
What are two delayed complications that can occur after blood transfusion?
Yeah. What are the complications? What are those?
Delayed hemolytic transfusion reaction.
Delayed hemolytic transfusion reaction. Next one. Acute lung injury. Simple listen. See, blood transfused, immediately patient collapsed. That is acute reaction. Sometimes after blood transfusion, after 2 to 3 hours, they will develop complication. That is delayed reaction. Okay, delayed hemolytic injury, hemolysis. So for that, you need to discuss some immunology. Cold agglutination, warm agglutination. There are two types of agglutination. Sometimes what happens was, this antibodies reaction happens in warm temperature, that is inside the body. When you have taken blood into a cold packet, the antibodies are neutralized. During this cold condition also, sometimes this blood packs are cold in temperature. We need to bring them to the room temperature. When we are not bringing room temperature and we are transfusing it to the patient, there might be any one of these reactions, either acute or delayed reactions. That is due to these temperature variations and antibody reactions. You just go through the material, you will understand. So that is cold agglutination and this one. That is the reason. Next question.
Explain the significance of the direct Coombs test in diagnosing transfusion reaction.
Yeah. What might be the importance of Coombs test? We already can know. Hemolytic disease of newborn can be detected. Erythroblastosis fetalis can be detected. Even, can be able to detect Bombay group with Coombs test. In Bombay group, what happening? Actually, there antibodies can be detected by Coombs test because his blood might be sensitized with those antibodies, his red blood cells, Bombay group red blood cells. Okay, so if a patient get a Coombs positive, there might be three reasons: disease, newborn disease, erythroblastosis, or bone condition can be there. Yeah. Next one.
7 questions, sir. Assignment 1.
Another important I forgot. See, accidentally you are a negative person. Accidentally you got a positive blood previously. Now when I do the Coombs test, definitely I can catch you. In your serum, I will catch your reactions because you are sensitized with positive blood previously.
Yes.
So the Coombs test has very good applications. It's very useful to detect such complications. Yeah. Next question.
So next assignment question.
Next assignment. Either assignment 1 or 2 will be your MST. Then
So why is it important to test for the secretion of A or B substances?
secretion of.
A or B substances.
What is the answer? Go to the answer then. 2 marks are at the bottom. A and B substances secretion. When we say secretion, that is A, B, AH and BH actually.